Welcome to the OWASP Devslop show once again. Before we start, I just, for the new people who might not be familiar with our project, we are called OWASP Devslop project. OWASP stands for the Open Web Application Security Project. It's a nonprofit dedicated to helping people build secure software, and I invite you to visit the OWASP.org website that just got a huge revamp, and find a chapter near you and learn about everything we're doing.
So Devslop stands for sloppy DevOps, because Nikki and I wanted to know, how can you pen test a DevOps system? How can you make sure that the software at the end is secure? And we both wanted to know how to do more things. So Nicole made a really super modern app, and then we punched in the face a lot. And then we learned a lot from that. And then I started streaming and just in like live coding stuff, and Nikki joined me and Nancy joined me. And then we started trying to just build our own pipelines and breaking them a lot. And then eventually the program matured and matured. And then we started inviting experts on in different areas to teach us really basically stuff that we want to know. We're like, how can we learn for free from experts? I know, we'll start a show. And it has worked. And everyone gets to come along for the ride, and it's pretty fantastic.
I think the other sort of goal that I think are all looking to achieve is there is a variety of solutions in the DevOps world, and it can get very complicated very quickly. And like, where are these checks going? How does it all get automated? Like, there's a big ecosystem here. So we are always trying to distill this into things that make more sense so we can use it better. I think that's, at least for me personally, that's a huge goal of mine. And I think we all collectively, I think the whole industry shares this goal, is how do we simplify this to make this whole thing a little bit easier to understand? So hopefully we are doing that.
So we'll get out of the way and start introducing Barak, and let him introduce himself. What I know, I forgot to ask you for your bio, Barak, and I read a few things online. But what I know is that I listened to a podcast recently, and your co-founder kept saying Barak's a whiz kid. He left for like 4 days, and we didn't hear from him, and then he came back with Checkov. So yeah, so please come and tell us a little bit more about you and a little bit more about Checkov and what you have planned for us today.
All right, yeah. Well, thank you, the amazing Devslop team. It's great to be here, and it's really, I've seen like great content and get great tutorials over various tools like OPA and Terraform Compliance and Terrascan. I did learn a lot of how to manage infrastructure security at scale. So to everybody else and to the panelists, hi, my name is Barak Shoster. I'm located not too far from Tel Aviv, Israel. I'm the co-founder and CTO of a company called Breach Crew with a similar goal to make cloud security very simple. I came out with Checkov actually as a result of past experience at my previous work. I tried to apply a large-scale cloud infrastructure in a big corporate, which was part of Dell Technologies. I used to work at RSA. And they had a lot of processes and policies that should have kept the DevOps team, which I was part of, and the platform engineers, which I was part of, under a very strict and good best practices of security when moving the infrastructure from the on-prem into the cloud, or from moving from the dev AWS account into the production one. And it was a very hard experience because a lot of teams, there was like number of security teams trying to apply policies. There was lack of knowledge of the DevOps tool that we used, which was Chef at the time, SaltStack, Terraform was just in the beginning, and also a bunch of Bash and Python for automation of API calls. And it was very hard to move fast. On dev environment, everything like just work. You could Terraform apply or run your Chef or Puppet or whatever it is. And it was not with the same restriction as production. And we really wanted to have the same experience for dev, QA, prod, and production accounts, and to move fast with building infrastructure. And at first I started with writing like a bunch of API call scripts to make sure that all of the policies are there. And there are a lot of good runtime tools like Prowler, which is one of them. If you haven't heard of it, it's scanning infrastructure using API polling. There is Stream Alert for alerting over changes in your cloud in AWS. And there are various projects in GCP and Azure, like Forseti and NCC group projects. All of them are open source, but it still was too late in the game. On a large scale organization of engineering, it's really hard to distribute all of those Jira tickets that, hey, you have this S3 bucket open, or you forgot to turn encryption on. If you have one that database, it's easy with one engineering team. But what happens if you have more than 100 engineers? It's really hard to distribute. And a lot of the work of the security team was to manually distribute tickets, Jira tickets of security issues of infrastructure. And I thought that there must be an easier way. And I saw the same experience in other organizations when we founded Breach Crew. And automation tools like Prowler was not enough to catch things early in the game. So we took the application security methodology of static analysis and tried to apply it into infrastructure code. And this is how we came out with Checkov. That is just checking, and also is a Star Trek character that is nice to follow. So let's kick it off. We're going to start with some slides, giving some context on the problem space, what's the current status of the open source security of those infrastructure modules. And we'll do that for like the first quarter of this workshop. And right after, we're going to do some hands-on for 3/4 of this workshop. We're gonna git clone an example project. We're going to run Checkov on it, going to write a policy, and the fastest in the team here would be able to actually contribute the first custom check. So let's see. So before starting, things that you should have deployed to follow along, and feel free to do that for the next 30 minutes. If you have any issue, please publish that on chat, and maybe someone will be able to pick it up and help. You need to have Git installed on your laptop, a GitHub account, which is free to open, Python 3 installed. You can use pipenv or virtual env to make it easier if you have multiple Python environments. Terraform is not mandatory if you don't want to apply the Terraform code. It's just giving some context. Python IDE, I will use VI, so you don't have, but you have to, but I would recommend to use PyCharm just for easier contribution. And an AWS account is really optional. I'm going to show a vulnerable account that I'm going to tear down right after this workshop. So you don't have to do the same. So just like if you want to discuss on some other projects after this talk, I am a contributor of various open source projects around AWS security, Google Cloud, and Azure. So Prowler is an API polling or runtime security of configuration in the AWS cloud. CloudMapper is a great project with a similar goal and with assets inventory features. RAM is a least privileged role open source project, Checkov that we're going to focus on, and Teragoat 2. CloudFormation Goat is vulnerable by design CloudFormation template, and there are some cool projects about pre-made modules that are secured by design for PCI environment in Google Cloud. So we do contribute a lot to the open source at Breach Crew and also as a personal hobby. If any of those projects interest you, you can feel free to reach out at Twitter. I can do my best to help. Or if you're interested in machine learning over cybersecurity, that's what I did for the past few years in my past roles. So I'll be happy to talk. All right, so we already went through the agenda. Let's talk about the problem space. So what we do need as engineers, like generic engineers, like security engineers, is to work fast and more agile and deploy the different infrastructure of our new applications in the public cloud. We need to do that without breaking the system, meaning without having a bad actor utilizing some of the issues that might come with the default configurations in the public cloud. So there was an interesting saying by Gartner that 95 of the issues that would be found in the public cloud by this year would be as a result of configuration error. And the reason is because you have over 200 services just on AWS. And if you're a multi-cloud, which is probably what happens when you're working on a large organization that have a lot of business units, it can be even worse. Because it's really hard to track all of those APIs and services when the ownership of those services are within a big and trustworthy third-party vendors, but it really is a lot of documentation to read of those configurations of the different services of the clouds. So what the challenges look like for engineers is to move fast, we need to codify every aspect of our work. We do not want to repeat ourselves with manual labor of changing every configuration manually, especially if I have like a whole data center that I need to program. So to stand up a server, which is an EC2 in AWS, that can be only a few lines of code. To stand up an IAM policy, also additional lines of code. And you do want to codify it because you want to have the same structure both in dev, QA, prod, or other environments while you're developing. You want to utilize as much as you can existing solutions. Obviously, you can build your own database and you can manage the auto scaling of it, but you really shouldn't because you have already managed key value stores like DynamoDB, managed Postgres databases like RDS or MySQL RDS, and all of those headaches of how can I really scale the application with the business are already managed within the cloud provider configuration. And it seems like most of those configurations and their configuration errors are taking a lot of time to triage on large scale environment. So let's say that I have an AWS environment and I have multiple teams changing the configuration of it. I need to work hard to triage it. I need to understand who made the last configuration change. Why did he or she made it? Does it have an acceptable reason to expose the risk? For example, maybe the database should be public because it's just demo data and you are just sharing it with an external organization. Maybe the S3 bucket is used for website hosting, so it should be public, and those kind of stuff. But it really takes time to triage everything. And on fast-pacing environments and hyper-growth companies, you have a usually or relatively small security team that need to chase all of those DevOps engineers that are changing the cloud configurations. I'm saying DevOps just as an example. Those can be usually SREs, cloud admins, platform infrastructure engineers, or cloud engineers. They have multiple names in various organizations. And those are happening a lot in the cloud providers and also on multi-cloud frameworks like Kubernetes that have a lot of knobs and switches that are really hard to follow. So if we would scan the entire open source models of infrastructure as code, what would we find? What are the kinds of issues that are out there in the wild when you look for a new Terraform module, for example, for a website hosting or VPN, etc.? What we decided to do in Bridgecrew is to use the open source utility called Checkov that runs static analysis over infrastructure as code and to scan thousands of open source Terraform modules and see what the default configuration is. So a default configuration can be changed into a secured one, but it is not secured by default. And we chose to emphasize that because usually what you will do as an engineer, like in Stack Overflow, is copy paste whatever the common solution is. So in a lot of times, you might choose to copy a solution that is not secured by default. So let's see the trend. So what we see here in this slide is the trend and the contribution phase of new open source modules to the Terraform registry, and it's skyrocketing, which is good for Terraform, and it's good for us because it's more open source code that makes us not to repeat ourselves. And here during this period, that's COVID. It means that work from home productivity is really working. And people are contributing more and more Terraform modules, which is great. More open source, less code for me. But how does that look like from security standpoint? So a lot of those default values in those Terraform modules are not secured by default. So we did approach some open source contributors during Q1 of 2020, and we showed them some of the results. So we've seen some drop in the amounts of misconfigs, but on Q2 we had some more modules contributed, and they had their own issues. So we have more open source code, we have more code, so we have more bugs with it, and more security misconfigs with it. And again, it's misconfigs of the default values. So if we will take all of the Terraform modules that can be misconfigured, it's around the 3 main cloud providers. Those are around 2,500 out of 3,000 and something possible Terraform modules. And 44% of them are misconfigured. From downloads perspective, those are several millions of downloads, because all of those modules together had 26 million downloads, meaning possibly 26 million provisioned instances of those resources, which is a lot. So let's take, for example, I have an EC2 with an EBS volume, a storage volume attached without encryption. If it was downloaded from the Terraform registry with a vulnerable module, and there are some valid the compliant modules. I'm not saying that you've chosen by default the wrong one, but if you did choose the wrong one, you could have provisioned an unencrypted EBS volume, and if you've done it multiple times, that could be millions of times. And how does the categories of the different issues look like? So we have a lot of backup and recovery that is not turned on by default, which is not only a security issue, it's more of a reliability issue or disaster recovery issue. Logging, which is really good for visibility, like S3 logging, Elasticsearch logging, RDS logging, to really know who is accessing what, is not turned on in a lot of cases. And I can understand why, because it has some cost implication from where you're going to store all of those logs. It's going to cost you storage money. But if you really want to have the best visibility, you should really follow this best practice. Encryption is not turned on by default, and usually it doesn't cost that much. So KMS really costs literally nothing, and it already does most of the key rotations, and it does most of the work for you. So there is no reason not to turn it on by default. Kubernetes has a lot of knobs and switches, so I can understand why it's misconfigured. General security is just something that doesn't fall to any of those specific ones. And we have like 9% of networking issues. Like we found modules with port 22 for SSH open to 000, which is the entire internet. And the good thing is that there is not a lot of IAM issues, so that's a good sign. From the different clouds perspective, AWS obviously is the highest contributed one and the most used one, and this is how the stats looks on the AWS cloud compared to the Azure and GCP. And if we break it down, the most misconfigured service in AWS is Kubernetes. In Azure, it's backup and recovery that is missed, and GCP, which is getting slightly worrying, is networking issues. And it's not because people are not knowing what they're doing. It's not because of Terraform. Terraform is a great framework to actually have a very constructed way of applying infrastructure to the cloud. For the first time, we have a very easy way to scan to plan our blueprint of a data center and apply it. And the fact that we use Terraform does not cause more security issues. That's important to mention. It's actually helping us solving them much faster because all of the code and all of the configuration is consolidated in one place. But yeah, sure.
I have a question. So you have 7 different categories on the right, but then GCP and Azure, or GCP doesn't have as many as, it doesn't have all of them. So when it's not showing up on this graph, does that mean they just did an awesome job and there were no problems?
So it is important to say that relatively there is not a lot of Terraform modules for the Azure and GCP cloud providers. So it might be that there is no resource or that there is no compliant configuration that we're aware of, and therefore no data.
So it doesn't mean that Google Cloud is like perfect at backup and recovery, because I was like, wow, that's amazing. And I'm like, I think I'm reading the graph wrong.
Yeah, so it's not like it's super secure. It's just we can only scan for the known knowns in static analysis, for the known misconfigurations that are possible. While Checkov has more than 400 best practices baked in, it's only the ones that we know of that are there. There might be other services that we are still not familiar with, or that the community, Checkov has more than 30-something contributors. Maybe the community is yet to be familiar with the best practices of those.
There's a question from the audience as well. It's from Trevor. So encryption appears to be pretty high for Google. Is it possible that the Terraform module authors are taking encryption for granted on GCP since the platform encrypts by default?
So if it's a service that encrypts by default, you wouldn't see it here. It's only for services that do not encrypt by default, or that have, if they have encryption by default, the value is encryption equals false.
Cool.
Yeah, but I
just
guess
a question.
Oh, sorry. No, for Trevor, I guess he's thinking that whoever's writing the Terraform script or code is not thinking about encryption because they believe that encryption is by default. That might be a reason why it's not enabled. I also, by reading your report, you were saying, Rich was saying that a lot of things were misconfigured because they were not defined, right?
Yes. So not defined means that you expect the cloud to encrypt it by default, and you haven't explicitly defined it in your code. And some of it is also because, like a year ago, you didn't have, let's take Elasticsearch on AWS, for example. About a year ago, they added, AWS added a force flag for encrypting HTTPS transit traffic. And it took like a month or two for it to arrive to the Terraform library, the ability to encrypt it. So you might have built the Terraform module while there was no such option. So this is another reason. But what I see mostly when I'm talking to people is just an educational gap. There are like 200 services. You cannot really remember all of those knobs and switches.
Yeah, just a quick question, Brock. On the Kubernetes bars, are those EKS and AKS and GKS, or is it like native Kubernetes on compute instances?
So those are the EKS, GKE, and AKS. Checkov does have the capability to scan Kubernetes manifests, but on this report, we were really focused on Terraform.
Got it. So it's Terraform provisioning, EKS, AKS, or G. Okay, got it.
Yeah. All right. So where do those bad configurations come from? You can take them like copy pasting from Stack Overflow posts of AWS, Google Cloud, and Azure, or from the blog posts. You can copy them from Terraform registry, where really everybody can contribute there. You can copy them from external GitHub account, from internal in your own company. Like if you have a platform team that is writing most of the Terraform code, it doesn't mean that, well, probably they are smart people, but it doesn't mean that they are aware of all of the knobs and switches there. And you can also do the mistake by your own. It's fine to be mistaken when writing code. You just need to learn and acknowledge it and be better over time. Yeah, and watch Powerpuff. So what we came out with is we have all of those tools, and we scanned it with this open source tool named Checkov. So a little bit of context and history of Checkov. So it was released last Christmas. Has a nice community around it. Within Bridge Crew, we have 3 constant maintainers. It already has more than 600,000 downloads, 1,000 stars. It's picking up pretty nicely. It covers 5 major frameworks for now, which is CloudFormation, Terraform, Kubernetes, manifests, serverless, and ARM templates. And you can interact with it just like any unit test framework. You can, just like if you're writing a Python JUnit or, a Java JUnit or PyTest, where you can give a skip annotation, you can just skip your Terraform code with a skip, or any other manifest with a skip annotation. It supports extensions, so if you want to add a custom policy that is relevant only for your organization and you don't want to contribute it back, which is a shame, but if you do want to contribute it back, you're welcome to be the 401 policy. If you do not, and it's relevant only for your organization, you can host custom checks within your GitHub repo, whether it is the Terraform repository or external one, and even interact with sharing policies within the organization. And you can integrate it to your CI/CD pipeline, and we'll see how to do that in this workshop. About the concept of policy as code. So what is a policy and what is an example of one? So let's say that you, by default, you don't want your servers to be public. By default, you want to have encryption turned on. You want to have WAF enabled and recovery and high availability configuration being used. So that's a policy. To define it in code and not on Confluence paper means that you can version control it. You can peer review the policy itself. In Checkov specifically, we're writing the policies in Python, which gives us the capabilities of a language like inheritance and code reuse and making API calls. You can automate it in the software development life cycle, and you can obviously integrate it to your CI/CD. So just as an example.
I have a question from the audience. Could the output be integrated to Security Dojo? Didar's asking that, and I'm wondering if they mean Defect Dojo or Security Dojo. They're saying Security Dojo.
I think it's Defect Dojo.
Defect Dojo. So I don't know if you know, Barak, but OWASP has a tool called Defect Dojo, which will suck up the results of many types of security tools and then show you kind of like analytics and metrics over time and help you track that the things are being fixed, etc.
All right. So the answer is yes. So Checkov has multiple output formats that can be used to integrate multiple tools. So it has CLI output format, which is obvious, but also JSON output and JUnit XML that are easily machine readable, and you can integrate that to any external tool.
Cool. The person says thanks.
All right. So let's take an example. So what I have here is just to give a reference of how easy it is to be mistaken. What I'm going to do now, I'm going to move my browser here. I'm just looking for the Terraform page for AWS DB instance. So let's say that I want a database in the cloud. And I want it, well, I'm an engineer, I will look for the first result and I will copy and paste it. And that's good because I want to move fast. So let's go to the basic usage. Yeah, I'm not doing anything special. I want a database. Let's use it. I will copy it and I will use it. What's the problem with it? That it is not, the basic usage is not encrypted by default. And it's violating my policy. So it's missing this flag or this parameter, which means storage encrypted equals true. And how does a policy in Checkov looks like? When creating a policy, you need to create a class that inherits from base resource check. The base resource checks will handle all of the formats, conversions, for example, the JSON and JUnit output formats, the CI integrations, etc. So you don't need to worry about all of this boilerplate. You just need to mention what is the name of the policy, what's the idea of it, and you need the identifier in order to skip it if you'd like. What are the resources that this check supports, which is AWS instance, DB instance, what's the category, which is encryption. And let's run on the scan method. And really, this is about it in the policy. It's looking for, is storage encrypted exists inside the configuration keys? And if it does, is it equals true? If it equals true, yeah, you can continue. It's passing. Or I see that I'm missing an enter here. But if it is not existing, you should really fail the policy. Failing the policy means that the policy is not permitting this specific resource to be committed or deployed, depends on where you're in the pipeline. So what we're going to do now is to use a vulnerable by design repository called Teragoat, and we're going to clone it live and see how to use it. How does a vulnerable Terraform infrastructure looks like? So let me make it slightly larger. So Teragoat, feel free to use it. Everything that I'm showing here is Apache 2 license, unless I'm saying otherwise. And I hope not to say otherwise. So Teragoat is a vulnerable by design Terraform infrastructure. It has 3 cloud providers with vulnerable configuration installed. So please make sure that if you provision this Terraform code into an account or a project or a subscription, remember to tear it down by running Terraform destroy. So what do you need to provision it? You need, if you're using AWS, you'll need to have a bucket deployed in your AWS account. You'll need versioning on that bucket and encryption turned on, just the security properties of that bucket. And then you can run Terraform apply, and it will provision vulnerable infrastructure in your cloud. And to destroy it, you are running Terraform destroy. If you want to have multiple stacks, like multiple vulnerable environments, you can have it. The same for Azure and the same for GCP. So let's start by cloning this piece of code. And I'm going to move the bash here. I'm going to write git clone and let it download to my endpoint. So it's a pretty small project, so it should be fast. All right, so I have this Teragoat project here. Let's take a look on what's inside it. There is a Terraform directory, and it has the 3 cloud providers. And within AWS that I'm going to focus at this workshop, there is multiple Terraform files. There is the EC2 Terraform, Elasticsearch, IAM, Elastic Container Registry, Kubernetes cluster, etc. So what I'm going to do now is I'm going to go into the EC2 Terraform file. Let's make it slightly larger. And this is the code that I have defined here. So I have a web host, which is common to be defined in a cloud environment. It has an EBS volume attached. snapshot, so it's good. I'm having backups. Security groups, which is the firewall configuration, a VPC, and a subnet, an internet gateway, a routing table, and networking, VPC flow log, S3 bucket, public DNS, VPC ID, and that's about it. So it's a standard 3-tier, well, the database is defined in another file, but it's a standard 3-tier web application. And what's the issue with it? So if I'll go manually, let's say that I'm the security engineer in this large organization that is reviewing the Terraform code that the platform team have written. So I will need to take a look at the code, like line by line, and do a code review. They will probably submit a pull request. And I'll need to, yeah.
Just a quick question. There's just a little bit of feedback to maybe just slow it down just a touch so that people can stay on target.
All right. So I'm going to give like a few more seconds to git clone it, and I'm going to repeat how to do that. So what you need to do is to go to bridgecrew.io/Teragoat, go to code, copy this code, this URL to clone it. And what I'm going to do is to git clone this URL. After doing so, I'm only up until now, I've only walked through the content of it, which is a standard Terraform code for a 3-tier web application. As a security engineer, my role is to review the configurations that are defined in this Terraform code. When doing so manually, I have this AWS instance, which is a VM, an EC2, defined in Terraform, and it has various issues. So the one thing that I can see like super clearly is, hey, I have those plain text access keys inside my Terraform code. Don't worry, Teragoat does not contain real access keys. Those are fake ones, but they are with the same regular expression, and they might have been. So it's starting an Apache server, and it's giving inside the environment variables in plain text those access keys. The best practice would be to keep it in some kind of secret storage. So AWS has the built-in parameter store that can store secured strings, and there is also a secret manager, and you can always provision the HashiCorp project called Vault. So there are various best practices of where and how to keep secrets. Why it is important to keep secrets? Because if an attacker would get those access keys, usually they will end in either crypto mining attack, meaning an attacker can utilize an overprivileged access keys to stand up new instances in the cloud, install a crypto miner, and get money out of it, like Bitcoin. And you will mainly get like a very high billing invoice at the end of the month, which is bad. So you should really keep those secrets in a matching storage.
There's a question. They're saying, or directly on the AWS account, does it matter?
I think they're trying to run Terraform scripts, and so if you do execute the Terraform scripts, it should create all that infrastructure for you if you fed it your right AWS access keys. So there's a lot of things I don't know about. I'll try to troubleshoot with
that.
Yeah, you should
Okay.
really do not try to apply this Terraform code if you're not familiar with how to apply Terraform and how to destroy it.
Yeah.
There is a full documentation here that you can run on right after you have your access keys defined, but do not feel obligated to do so. I am going to demonstrate on an environment that has those provisioned. So we're going to demonstrate a vulnerable environment. You don't need to do so. You can only review the code with me, and we're going to review it right after with an automated tool to have those done for you. Does that make sense? Does that answer the question?
Yep, I think so.
Right. So I'm going to show you what happens if you're provisioning those resources to the cloud. I'm just going to do a little MFA here. All right. So let's take a look on S3 buckets in my account, for example. So I have all of those buckets defined, and hey, I have a data bucket that is public, which is bad. Where was it defined? It is actually here in this S3 Terraform code file. So I have this data bucket with this data suffix that has public read, meaning everybody can access this S3 bucket. And I have all of those other resources that there is nothing out there outside of Teragoat, but they are could be very sensitive buckets in a real environment.
Quick question.
So, yes.
Sorry. What's the difference between public and could be public or can be public?
Right. So there are AWS policies is hard. And there are multiple ways to configure a public object in S3 bucket. You can say that the entire bucket, like everything that is under a bucket is a DNS record. You can say everything inside this DNS record is publicly accessible by everybody. And you can say, hey, not everything is public under this DNS record, but specific objects or directories, files or directories within this bucket can be public. And you can say, hey, nothing can be public under this DNS record. So those are if I try to simplify it, those are the main three stuff that you can do. But you can also have an S3 bucket that is public, but everything inside it is encrypted, and no one has access to those encryption keys. So those are like having a public bucket that is really not that public. So this is an example of a public bucket that is really hard to decipher. Right. So if you will apply Teragoat, you will get a similar environment to this, where the first stage is how to create a remote state, where Terraform saves what are the resources that it's going to provision or have provisioned. And the other resources are those vulnerable by design resources that I have defined in Teragoat. Right.
Excuse me, Barak. So somebody's asking to make your AWS console a bit bigger when you get to it. You're in GitHub right now, but when you're going back to there.
Oh, while you're doing that, another good question just came in. I think the question is really, can you use Checkov to validate that S3 buckets have the appropriate tagging that is required?
Yes, you can. So tagging is a custom policy you can write. So since tagging is implemented very differently across multiple organizations, it's not one of the baked-in best practices. But you can write a custom policy of how to that validates that an S3 bucket is being tagged by a specific convention. And I'll show an example on how to do that later on. If you remind me when I'm starting to write custom policies, I will do that.
So there's one more question. Is Checkov named after the character from Star Trek?
Yes, it is. So
that's fun.
I'm actually a Star Wars fan, but guy. My partner is a Star Trek fan, and I had to lose in this bet. So. And
I like the question.
It was more catchy than Chewy and more related to checking stuff. So yeah, Checkov is related to Star
I
Trek.
like it.
Yeah. So I have this bucket that is named Acme Dev Data, and if I'll try to understand what's the code that caused it, it's actually these lines of code inside the s3.tf file. So I have an issue here. I have written Terraform code, I have applied it as an engineer, and I have a vulnerable AWS account. What can I do to solve it? So there are tools within the AWS framework, like AWS config that is available in your AWS account. There is Security Hub, there is CloudWatch Alerts and CloudRail and GuardDuty, and those will tell you the same. Hey, you have an issue. You have provisioned a bad resource. What I'm asking myself is, could I prevent it? What can I do to really understand before provisioning a resource to production that it has issues within it? So if everybody have cloned by now Teragoat, what we are going to do now is to install the next tool, which is Checkov. So it's important to say that Teragoat is just an educational tool. It's not Checkov. It's a vulnerable by design repository. You can run Checkov against your own Terraform directory, and it will show other results, but with a similar pattern. So what I'm going to do now is to use pipenv. Pipenv is a utility to run multiple Python frameworks versions. So I have Python 2 and Python 3 installed on my laptop. So I'm probably the only one that needs to do that. But I'm going to start creating an environment and running it, pipenv shell. And it is very similar to running just the next command, which is pip install Checkov. What it's doing by now, let's take the latest version. What it's doing now, it's downloading the latest assets from PyPy of the project Checkov. Just to give, while you're doing pip install Checkov with or without -u, I'm going to go into the GitHub directory of Checkov just to give you a quick walkthrough on the documentation. So if you will look Checkov in Google, you will get it. But another option is to go into bridge.io, github.com/bridge.io/Checkov. So it is in a good state for now. Very highly maintained project by us. And it has a lot of coverage on tests and security. We're running Bandit and Detect Secrets and a bunch of other tools to make sure that this open source utility is very, very safe for use by you. And it is really being used in multiple organizations and have like a lot of downloads. If you have any issue with it, open an issue and we'll do our best to apply a fix as fast as possible. Either us or anybody else from the community contributors. So what we're going to start with is the official docs. So let's go into docs and go to getting started. So what I've done up until now is the same as defined here, which is pip install Checkov, and I have it deployed here. So if you go into Checkov.io, introduction, getting started, you will see right after this workshop the same walkthrough that I'm going to do now live. So I've installed Checkov on my endpoint, and what I'm going to do now whoops, I'm not in the right directory. I'm going to go back into my Teragoat directory. And what I want to do is to scan the Terraform directory. Specifically, I want to scan only the AWS one.
We have two questions, Barak. Sorry to interrupt you. So one question is, pipe environment or pipe NV is a virtual environment where you are running Unix, or are you running it on Unix?
So I'm running. My laptop is a Mac. I forgot to mention that. Let me pull up a slide here. You can run pip install Checkov. It's the same on Linux and Mac. For Windows, you would have to use some environmental variables tricks to make Python work if you don't have it installed and it's your first time. But you can use the Docker utility, which you will get from Docker pool bridgecrew/Checkov. And the documentation of how to use Docker is on the markdown of the GitHub repository. You can also use brew if you're a Mac user, and it will install virtual environment or pipenv for you with Checkov within it. So there are 3 options to use it, and you can choose any one of them, both for Windows, Mac, or Linux. I'm going to keep it up to keep this slide up for a few seconds. What I'm going to do now is I'm going to go back to the terminal. So what I've executed after pip install Checkov is I have executed Checkov -d, which stands for directory, and I pointed it into the following directory, which is Terraform AWS, the directory that contains the ec2.tf file that I've shown before, and the directory that has the S3 bucket that I've shown. What I get from it is a full report of both passing and failing checks, with links to guides of how to solve those. So over here, I have a passing check of an S3 bucket between lines 1 and 13 that does not have public write access, meaning not everybody can write for it, which is good. And I have 44 more passing checks, meaning 44 additional checks that are in a good state of best practice. And after going over all of those passing checks, that I'm not going to drill down on those, I have those failing checks, meaning checks that I really should fix. And the context that the Checkov output gives me is, hey, this is the name of the policy. You don't have S3 bucket that is encrypted by default at rest. The resource name is AWS S3 bucket data. The file is s3.tf between lines 1 and 13. And this is the code that is vulnerable. And I do have this public read, but what is missing here is the encryption code block. So what I can do, this is an open website. You don't need any kind of username to see it. Those are policies with the configuration and rationale behind them with a deep description, explaining more about the policy and how to remediate it. So it's a complete, you don't need to sign up to see those policies and how to remediate them. So I have this, yeah.
Oh, quick question from the chat. If you had to add an exception to some of these policies, like for example, not all S3 buckets should have versioning, or maybe you can allow write-only access to the world, right, for some reason, how would you do that?
We'll show that in a minute.
Cool. Thank you.
So I have this build time resource of S3 bucket, and what the guidelines is showing me is, hey, you should add this code block to encrypt by default using AES algorithm. So what I should do is go to that specific file and add this code. And I have more and more issues, and let's look for those plain text access keys and see if we caught them. And there is also some variable interpolation things. For example, if I have an AWS DB instance that has a variable that is generated, Checkov does some of the variable interpolation for you. So for example, you have here password equals var.password. Checkov will say you, hey, we evaluated that value for that specific expression. So it does some variable solving. And it also identified that I have SSH port open to the world and others. So going back to the question that was asked, can I skip a specific policy? So let's focus on a new file that we will create, and we'll see how to skip it. So I'm going to go into the AWS directory and open the S3 file, for example. I'm going to copy this specific resource. Sorry, I copied 2 resources. I'm going to copy only one. I'm going to create a new directory called make dir OWASP is cool. And I'm going to, inside this dir, create a new Terraform file. And you don't need to follow up this one. It's just to answer the question. No need to code it on your own endpoint. And what I'm going to do is to paste this S3 bucket. And what was asked is it allowed? How can I skip the policy which says public read is actually allowed? So I'm going to just delete those comments. This is a normal Terraform code without comments. What I'm going to do is I'm going to skip a policy. I'm going to open now the Checkov documentation, open up suppression category under concepts. And there is a comment format that is called suppression, Checkov suppression, Checkov skip. What I need to do is within this specific Terraform code, I need to write the check ID number for a public policy, for a public read, and a comment. So I'm going to open the list of policies that I have here, and I'm going to look for public oops, I need to make the website a little smaller. And here I have Checkov number 20 that should allow public read. So I'm going to write the Checkov ID, Checkov AWS 20, and let's find the reason for the bucket to be public. I can say those are website assets.
Cool.
All right.
So, Barak, I think we are going to take a 5-minute break. Nancy, is that correct?
Yeah, let's just take 5. I know that
Yep.
it's a short workshop, but just 5 minutes and then we'll come back. Is that okay with everyone?
All right.
Okay.
Cool. Coffee time.
Caffeination for everyone. You're doing really great, Barak.
Yeah, this is great.
Thank you.
Okay, everyone pause, go get more caffeine, do your thing. We will all be right back. Before you start, we actually have a question that came up during the break in the Q&A section. So Can we run this tool against existing Kubernetes clusters and AWS cloud infrastructure apart from the Terraform files?
All right. So yes, there is. Let me share my screen. Okay. So if you use Checkov on Kubernetes projects, let's take. There is a very cool project by a cool dude named Maju. I really recommend to follow him. He has great talks in Black Hat, and he also arranged a bunch of meetups. I'm not sure if he was in Devslop, but he produces really great content. And there is a great content piece named Kubernetes Goat, which is similar to Terraform Goat. And it is a vulnerable by design a set of Kubernetes manifests break down by scenarios of possible attack vectors. So it's also open source, like everything else that we see here. This time MIT license, but you should be safe to use it. And there is a great Katacoda tutorial with step-by-step with scenario of how to identify those vulnerabilities and issues within the manifest of Kubernetes cluster, where there are like 14 scenarios that all of them can be detected using Checkov. So Checkov, if you clone this project and run Checkov against it, you will get a very similar experience of having this CLI report, colorful CLI report with links to the guidelines, showing you how you should remediate that manually using those guidelines. All right. So it can be done using Checkov. This is just a project to demonstrate that. This is Madhu. And if you want to follow the guidelines of how to do that live, let's see, it should be somewhere here. Introduction, getting started. So there is an additional flag. By default, Checkov will scan all of the frameworks, CloudFormation, Terraform, Kubernetes, serverless YAMLs, etc., and ARM templates. But if you want to mention only a specific framework, like scan only my Kubernetes manifest and skip everything in Terraform, you can do that using the ---- framework flag in addition to -directory to scan only Kubernetes manifests. Just to go back to where we were before the 5 minutes break, what we demonstrated is how to add a skipped section and tell Checkov to skip a specific check. So what I'm going to do is show you how it looks like. Also right here in the docs, so you'll get a reference to how to do that when you're doing that, when you're doing so back at work. So you add something like this, which is a comment, Checkov skip, a specific identifier of a Checkov check, and the reason for it. And the reason for it is really used for you to track of and remember why you did that, why you accepted that risk. So if you have a public bucket, it's not mandatory to put the comment of the reason, but it really helps to keep the knowledge within the organization. You might want to share the reason with other engineers during the peer review of the policy. You might want to remember for yourself. So instead of writing that in a notebook or a sketch, put the comment of why it's an accepted risk within your code. That's the best practice. And then the output you will get in the CLI command is that a specific check is being skipped. All right. Specifically for Kubernetes manifests, we're using the Kubernetes annotations inside the metadata of a pod, which is a slightly different format. And you can use this specific annotation to skip a check within Kubernetes manifests that have a slightly different format. the next question would probably be, what happens if I don't like the Checkov scans, all right? It has 400 policies. I really don't want to enforce all of those within my organization. What can I do to use only specific checks or skip specific checks? Allow list and deny list. So Checkov has 2 additional flags that you can use to skip a specific policy across all of your infrastructure. So let's say that I have 20 buckets defined, that I want all of those buckets to be public. Instead of, and I want to allow my organization to always allow public buckets. Or more accepted one would be, it is fine if you don't have versioning turned on because you have everything backed up somewhere else. So you can use the ---- check and define a set of check IDs that are allowed to be executed, or use the deny list, which is skip check. And you can mention those with comma separation. And then the specific check would not run across any of the resources that are defined. So if I'll have here, let's run Checkov for example, for a second. Let's run Checkov ---- Let's clear the screen for a sec and run Checkov -h. So it has a bunch of flags. The basic one, which is the mandatory one, is -d for directory. And you can also run Checkov on a specific file. There are additional ones regarding skipping. So there is the -c and -skip check and -skip check. And some additional flags that you might want to use. You can use Checkov if Checkov finds a specific resource that is not applying a policy, it will have a bad exit code, like exit code 1 and not 0. So if you want just to see the comments without having a bad exit code, and this is important usually for CI/CD integrations, you can use soft fail, which will suppress the exit code and will always go with exit code 0. You can choose to filter the guides from being displayed, the links to Breach Crew IO docs. You can attach an external directory that has custom checks, and we'll go over it in a few seconds. You can skip showing the passing policies and display only the failed ones. You can run on specific framework. And you can choose to integrate that with the Breach Crew SaaS offering that is not mandatory. You can use the Checkov tool as is and get the best out of it. All right. And there's also list checks that gives you a pretty print of all of those baked in checks that the community is maintaining for you. So those are, this is a long list of 421 checks. So you might want to ask yourself why we are using Checkov and not other tools like OPA and ConfTest and others. So we find it the easiest to write checks in a familiar language like Python, and it gives us the most advantages in having a reusable piece of code, which is a Python class or a method. And Checkov has the largest amount of content that comes with it and is maintained by the community. So if you find an issue with a check, it will be fixed. If you want to contribute another check, we would love that. All right, so let's go back to running Checkov on our Teragoat project. So I have I'm going to remove the OWASP gear. All right, so I have this Terraform code, and I've scanned it, and I'm going to scan it just one more time, showing only the failures. Quiet, Terraform, AWS. minus D. Right, so I have the report only with the failing policies on those resources. So I know that I have 37 issues in my environment. Let's fix one manually and see this counter dropping. So I'm going to open the documentation for AWS S3 bucket. And also this documentation that helps me define encryption and trust.
We have a question.
Yes.
So someone is asking, what is the difference between Checkov and a commercial tool? Are you both checking against the CIS benchmark standards, or are you covering similar things? I guess it would depend on the commercial tool, because you don't know what the commercial tool is covering.
So was the question about breach whose commercial tool or other commercial?
So they didn't say which commercial tool.
Right. So obviously the main thing is that Checkov is open source and community maintained. And there are commercial tools like ours that was created the open source and have adopted it and incorporated it into the SaaS offering. There are commercial tools that are using OPA at the back end, which is also common. The main advantages that are that exist within vendors is that other vendors might give you the ability to monitor both runtime environment and build time environment, meaning both monitor the provisioned resources live, whether they were provisioned manually or using infrastructure code, while Checkov is only focused on build time assets like infrastructure as code frameworks, without knowing what is provisioned actually in the cloud provider. The breach-proof platform is the same, is giving you the possibility to monitor both and some more capabilities. But
I have another question in the chat. Would it be possible to define multiple outputs for a single Checkov scan? In this person's GitLab CI pipeline, they'd like to combine both CLI and Junitix or Junit XML outputs.
yes,
so is it possible? Oh, sorry, I'll let you go.
So JUnit XML, let me open a slide on it. The nice thing about it is that's a screenshot of JUnit XML output from a code build execution. So code build is a CI tool within the AWS services. So if you choose to use Checkov with minus JUnit XML within code build, it will create this nice report with this NiPy of past checks versus failed checks. And you can have like a similar experience within Jenkins that supports JUnit XML's report, and I think that Circle CI does too. So the question was, if I run Checkov against multiple directories that creates multiple JUnit XML reports, if I understand correctly, would I get a single report or multiple ones? So the answer is Checkov JUnit XML format, Checkov gives the output in a full report of JUnit XML format. If you have multiple JUnit XML formats, those are multiple reports, and it really depends on the build tool that you're using or the plugin of the build tool that you're using, whether it can display multiple reports or not. So code build, as an example, supports, if I remember correctly, only a single JUnit XML per build. So you will have to run a utility to combine multiple JUnit XMLs into a single one if you want to have all of those under one. But really, Checkov usually should be executed against a repository. If you have multiple repositories, those are usually translated into multiple builds. And we'll get to that. If someone lost us in this explanation, we'll get into how to run Checkov within a build, like in a few minutes.
Okay, cool. So to go back to the question before, basically, there's no dynamic monitoring with Checkov.
No runtime monitoring with Checkov. No.
Okay, perfect. Cool.
It's only
Thank
a
you.
static analysis on code files.
Cool.
Right.
Awesome. Thank you.
So I've executed Checkov on locally, and what I got is this nice report showing me issues. But I don't really want to execute Checkov every time I'm writing code. Like it's hard to remember to do that, and I have like enough things on the top of other things on the top of my head. So I can integrate Checkov with a pre-commit hook. And for those who are not familiar with pre-commit hook, it's a YAML configuration that integrates with your Git utility that is installed on your laptop and will prevent from a new problematic code to get into the Git repository. And the pre-commit hook installation can be different between different kinds of operating systems. So we're going to skip this specific phase, but I'm going to show you the documentation page that will guide you how to do that. So if you go to Checkov.io integrations, and you will go into pre-commit, you will just need to copy this specific configuration and tell Checkov to run on all of your TF files. And by that, every change you're creating to a new Terraform code that is not valid from Checkov perspective, against all of those 400 policies, it will fail the commit, and you won't be able to commit this change to GitHub. All right. There is like if you look for pre-commit hooks, there is like tons of YouTube tutorials of how to do that. It just takes time. So feel free to go here, file an issue, or you can ping me and I can try to help you. So there was a misconfig in the cloud and it's gone now, right? Because we fixed it using the Checkov guidelines. So not really. I'm not a single engineer in an org usually. Usually there are more than one cloud engineers in the organization. And not everybody are integrating pre-commit hooks or downloading Checkov into their workstation. So how can I govern and make sure that every change in my environment is being executed with Checkov? So this is the architecture that we're going to do. Whenever there is a change request in GitHub to an infrastructure code, we're going to run Checkov, and we're going to have those infrastructure security tests executed, either approved or rejected by Checkov, and then we can start the deployment trigger into our AWS account. So how we're going to do that? There is actually a community contributed. This was contributed by a very nice person from Holland named Mavarkis. And he decided to contribute to us a Checkov GitHub action. So thank you. And we're going to execute it now against a fork of Teragoat. So let's do it live. Just to give slightly more context, the result of that would be an annotated comment on every change that I'm doing to my code with this GitHub action, a comment that says, hey, in this specific resource, you have these plain text access keys. Please fix that. And the build has failed. So let's do that. And I will start to do it. I will try to do it with the amount of time that we currently have. So here is Teragoat. What I'm going to do is I'm going to fork it to my personal account in GitHub. It should take a few seconds if you're doing that live together with me. All right. And while that's happening on your GitHub accounts, what I'm going to do is I'm going to open GitHub Actions, and I'm going to search for Checkov. Oh. Here it is. And what I'm going to do now is to take an example of a job. And I have an example project that I can copy right here. Of a Kubernetes, of GitHub Action manifest. So for those who are not familiar with GitHub Actions are relatively new CI/CD tool that enables you to run on a very standard GitHub repository a set of builds with rules. So I'm going to create a new file named build.yaml. And what I'm going to do is I'm going to run on every pull request a job that takes the Checkov action with directory example, directory dot. So I'm going to run a scan on all of the directories inside the pull request that I'm going to create. So I'm going to commit the following file to master because I want the GitHub Actions to start directly on the next pull request. So just going over again, I created a Checkov job that imports the bridge crew Checkov action, and I told it to run on the current directory, on all of the files in current directory. I'm going to commit this file directly to the master branch. If I go to actions, I can see that there was a new one added. And what I'm going to do now is I'm going to add a file just under the root directory just to demonstrate how that is being done. I'm going to create a new file called s3.tf. This is my Terraform file. And if I'm looking for a vulnerable file, where can I find one? Right, in Teragoat. So I'm going to copy just one of the files to demonstrate how a CI/CD pipeline looks like. So let's copy those. Let's copy everything and add it to this new file and create a new branch called new S3 buckets. Let's create this pull request. And after a few seconds, what I should see, like, here we go. I have this GitHub action that is starting to be executed. So it's going to take a few seconds. So I'm going to walk over what I just did again. All right. So I created a pull request with some new S3 buckets. This could have been an engineer in your team creating a new S3 bucket. And what I'm going probably to do is I'm going to tag some reviewers. Maybe, so there is no one in my fork, but if it was, if Tanya or Nicole or Nancy and I were developing in the same team, I would probably tag them and ask them, hey, can take a look on my new infrastructure. And they were like, yeah, you did an awful job. So let's take a look on if I've configured it correctly. Well, it seems that not. So let's go back to the action. So I think that I have an issue here. And I'm going to go back to the Checkov action because I probably missed something. So, oh yeah, I just checked out and I forgot to add the execution step. So, so this is how your Checkov action should look like. First, check out the code in the pull request. Second, run Checkov on it. And it obviously won't run Checkov on it if there is a missing step. So this is what I missed. And I'm going to update the Checkov action. And I'm going to update my pull request to pull the latest. So pull request. I'm going to update this branch with the latest GitHub action. So sorry for this distraction. If you will do the GitHub action as planned and as mentioned in the docs, that shouldn't happen. So let's take another look on this pull request and see how the execution goes now. While I'm doing that, so here there is the Checkov action stage that was missing. So while I'm doing that, just some I'm often being asked about costs. So if you do not provision any Teragoat resource to your cloud, it doesn't cost you a thing. Checkov action or GitHub actions are free up to a certain amount of execution, like a huge amount. You need to be writing a lot of code and doing a lot of commits for you to pass that threshold. And only then it's being, it will cost you money, and it is free for open source public repositories. So what I can see here is that the build has failed. And I have a pull request that has some passing resources, but it has also some failing resources that I really should fix in my code. Let's go back to that pull request and see that those results here. And I have those comments on top of my code, which really gives me the right context of, well, better context than CLI, that, hey, you have this code block and you should enable MFA delete protection on it. And over here, I have some other issues, and it also found issues in other files that I have. So I should really fix all of those before being able to commit those into my cloud. And I have those checks failing. So instead of having a security engineer reviewing line by line of my Terraform code, I can have an automated GitHub action to put those comments for me.
A quick question around the checks that you have across all of the, I guess, 4 cloud deployment languages: Terraform, CloudFormation, ARM, Kubernetes, right? Maybe those 4.
And serverless framework.
And serverless framework.
5
Are there?
Serverless framework is there.
Yeah. Are all the checks, like, I guess my question is, like, the Terraform checks, are those represented as well in CloudFormation, like equivalent? Or is there, like, is it better to use Terraform? I mean, I know there's a lot of complications around which infrastructure as code templates do people want to use, but I'm just wondering in terms of Checkov, is Checkov more opinionated? Is it better if you're using this against Terraform than CloudFormation or that kind of stuff?
Right. So it has the highest coverage in Terraform because it was ignited as an idea of how to scan our Terraform templates, because our SaaS offering and our customer SaaS offering is mainly maintained in Terraform. But then we started to see that if you're an enterprise and you have like a lot of engineers, things are really getting out of control. And you're seeing more and more frameworks, like serverless framework to provision resources like Lambda functions, but also to provision DynamoDBs. And people are running CloudFormation if they're AWS only shop. So we gave the capability to contribute additional checks in other frameworks, but the highest coverage for sure is within Terraform.
Cool.
I
That
have a
doesn't mean
question.
people can't commit. No, I'm just saying it doesn't mean you can't figure out your own CloudFormation scripts and recommit it, pull request it, and commit it back to Checkov, right? It's the whole point of open source and community. Cool.
Yeah, exactly.
Can you set it so that it doesn't break the build, but it still reports problems to you?
So the Checkov action, so GitHub Actions supports reporting issues inline only if there is a bad exit code. But if you want to see that on the CLI output, you can use the -- quiet, and you will see that on the GitHub Actions CLI terminal output of your issues. So you can, but you lose some of the capabilities with it.
But let's say, you know, it finds something really awful, but you want to let it go through anyway. Like let's say you're running it for the first time and you just want to see what's happening, but you don't want to break the build. Do you have the option to make sure it does not break the build?
Yeah, you can use the, so let's go back to the Checkov action. You can use the flag quiet.
Cool.
Oh, sorry, not quiet. I'm going to open the Checkov documentation again. So I want to, I won't misguide you. So there is soft fail flag.
Soft fail.
If you put
Correct.
soft fail equals true, it will not fail your build, but you will see all of the output.
Awesome.
So what we see open source users do is, let's say I'm a security practitioner, so I'm only in the beginning. I want to start enforcing policies, and I don't want to be really the one to block innovation in my organization. So what I would start with is, hey, let's show this output to people, to other engineers, let them fix it some. I will fix some by myself. And at the end, when I'm going to 0 or to an acceptable amount with some skip checks, I can change the flag off and start failing the build for every new change.
Perfect. Thank you.
All right. We're almost out of time. So just to give context of how to write a custom check. So I'm not going to do that live, but I'm going to show the documentation of how to do so. So let's say that I'm going to make it a little larger. Let's say that I have this code, and I want to enforce a policy only on a specific tag. So for those who are not familiar with PCI restrictions, PCI are restrictions or some kind of compliance benchmark to help companies that hold credit card data or sensitive data that relates to those under a private networking, for example. That's one of the restrictions there. Or a segregated networking would be the matching term. So let's say that as a security engineer or a cloud engineer in a bank, I want to have a specific policy only for resources that has the tag PCI or in scope. What I can do is I can, alongside my Terraform code, create another directory with an init.py and a custom check called S3 PCI private ACL. And I want to make sure that only PCI scope checks has private ACLs and enable public resources, public S3 buckets for non-PCI tag. So this is the name of the policy. What I need to do is to create a new class of check that inherits from the base resource check, create an ID for it, choose a category, and then run configuration check. If there is a tag with the key scope that equals PCI, fail if it has some kind of public access configuration. Otherwise, pass the check. Then you initiate this check, and on Checkov, all you need to do is run it against your directory with an extra check there, which is your directory that you just created. If you want to create a repository of checks and share those in your organization, there's another page of how to do so, which is sharing policies. And you can load the external checks directory instead of from a local directory. You can load it from Git with a specific path to the directory that has those codes. So what this code will do, it will clone the repository that you have for custom checks that you've built into a specific directory and will import that into the Checkov library. So all of the JUnit XMLs, all of those comments in GitHub, those are automatically imported, and you get that from the engine. You should only keep, you should only write the logic around what do you want to check. Right. So before wrapping everything up, few things that are important to mention. You do want to enforce Checkov in many places, in as much as many places as you can in your software development lifecycle. You really don't want bad code to be an example for others in pull requests. So you want to put a pre-commit hook. And you don't want engineers that haven't deployed a pre-commit hook to deploy one into the main branch that represents usually production. So you want to create some kind of CI integration that can be Circle, GitHub Action, whatever, or Jenkins. And after you're having that, and let's say that you are enforcing all of those built-in policies, you really want to start and fine-tune the policies that are right for your specific organization. For example, enforcing tagging policies and enforcing communication between specific resources only by the specific logic that you're aware of. After getting all of this done, what you can do is display a report that everybody can relate to. Hey, we started with this pie chart of having only 5 passing checks and 1 error, and now we have 0 or a more acceptable amount, and talk about the trend and education of infrastructure security. Before wrapping up and saying thank you to everybody, if you want to contribute code to any of those projects, you're most welcome, and we will highly accept it, and we'll be really happy about it. There is another open source project about least privilege called RIM. You should probably take a look around. And if you have any questions, now would be the great time, or you can ping me on Twitter or email.
Everyone's saying lots of nice stuff. I am agreeing with the nice stuff they're saying. I'm going to check out IAM, like,
yes,
that's really cool, identity access management. I want to check that out. I'm assuming it's going to be kind of similar to the Netflix tool, RepoKid.
So just a few words about it. RIM input is AWS access keys, and the output is least privileged Terraform code. So let's say that you have an IAM policy that is overprivileged, and you want to automate the code generation of a least privileged one. RIM is the tool for that. It will take you a few steps there.
Cool. Thank you. That's awesome. Oh my gosh, it's really cool that your company is outsourcing so many tools. That's amazing.
Yeah. No, and it does feel like it's easier to write Python rules or Python checks than maybe Rego rules and OPA. Yeah. I'm not sure. Do you have any opinion? I mean, I know that's like an awkward question, but just wondering, like, did you look at OPA to like try to solve, or OPA rule writing? Is that what forced Checkov? Like, were you?
So, yeah, that's a great question. So first, I want to say that I think both are great tools.
Yeah, totally.
I think that OPA, and it's great to have a community behind them. OPA is, as far as I know, can run on the plan files, meaning you need to apply variables in order to get the output. And we really wanted to make the integration with a static analyzer as seamless as possible. Even people who don't know what are the variables for plan, for example, what are the access keys for production, we wanted to give them the output of a check. So this is one reason. And we really felt much more comfortable with Checkov, with Python, sorry. So
sure.
More security engineers felt very comfortable with it instead of learning another language, because you already need to learn so many languages, the Kubernetes manifest and the Terraform. All of those are configuration languages, not like real languages, but it's really enough to learn. So we wanted to
They're
something to be
opinionated.
familiar.
Yeah.
Yeah.
So it's just yet another opinionated thing to learn.
Yeah.
Yeah, I get it. No, this is great.
Yeah, this is so great. This is really, really great. Someone in the chat is like, we should have one session where we bring all of the tools together. I'm like, oh my gosh, that would have to be a week-long session.
That's a day. Like, yeah. It's a conference, a Devslop conference.
It's a marathon.
Yeah.
But what would be great is to get, I know that we've spoken to Nimrod, I think, who's working on AirIM, to have Nimrod come in on the show or maybe a workshop. We'll see. We'll talk about it, see how this one went and get your feedback, Barak. But I think everybody here appreciate it. What I'll say before we leave is don't forget, I don't have a slide for it, but probably we'll put that in the chat. We're everywhere on social media, on Twitter, LinkedIn, YouTube, Instagram, I think. So follow us somewhere. Meetup group, I think, is a good place to know what we have coming up. We're going to take a few weeks off. I think we're back in August, mid-August, with another presentation. And follow us there and see what we have coming up. And if it's of interest, please join us live. That's always fun to have you and interact with you while we're doing these shows. So keep following.
Awesome. Thank you for being on our show and sharing all your knowledge with us and everyone in the workshop. That obviously took a really long time to prepare, and thank you.
And thanks for writing Checkov and open sourcing it.
Yes!
That's even more impressive. If you did write it in 4 days and
in
you came
4
back.
days, yeah, I was really impressed with that.
Yeah.
It was a guy, I guess. Awesome. So I'll stop the stream and say bye to everybody. Thank you.
Bye, everyone.
Thank you for having me. Bye-bye.